Hello, today's topic is mole concept and concentration expressions. Mole concept. So first of all, what is a mole? Mole is a unit to measure number of pieces, number of units, number of particles. Just like pair, dozen, like in a pair of thing, you get two pieces, right? A pair of shoes as it is shown here. A dozen of things. That means 12 items will be there. Like a dozen of eggs will contain 12 eggs. Similarly, mole, 1 mole means 6.022 times 10 to the power 23 number of particles. It is also called as Avogadro's number after the scientist Avogadro. These particles, when we are talking about particles, it may be any species. It may be atoms, molecules, ions, subatomic particles like electrons, neutrons, protons, anything. Why we should know about mole? What is its significance? Molar mass. That means mass of 1 mole of substance. That means where 1 mole number of particles will be there. So when we talk about molar mass of sodium, then it will be 1 mole of sodium atom. How much it is weighing? When we are talking about molar mass of helium, that means 1 mole of atoms of helium gas, how much they are weighing. So molar mass means number of mass unit expressed in gram for 1 mole of substance. Similarly, molar mass also means 1 mole of molecule. Like 1 mole of water, the molar mass will be 18 gram. 18 is the molecular weight of water molecule. So molar mass of water molecule will be 18 gram, expressed in gram. So the relation between moles mass and molar mass. Mole will be equal to given mass of substance divided by molar mass. So obviously it is used to relate mass, number of particles and volume of gases. So now we will learn few concentration expressions. First, molarity. Capital M is used to denote molarity. The definition of molarity is number of moles of solute per liter of solution. That means per liter of solute plus solvent, the volume of both solute plus solvent together expressed in terms of liter. So formula will be molarity, capital M, is equal to number of moles of solute divided by volume of solute plus solvent, total volume expressed in liters. Obviously, the unit will be moles per liter. Example, 1 mole of NaCl means 1 mole of NaCl dissolved in 1 liter of solution. This 1 liter of solution will include both the volume occupied by NaCl, sodium chloride salt, and water. Right? Okay. Normality. The definition goes as gram equivalents of solute per liter of solution. Again, another way to express concentration. Gram equivalents of solute per liter of solution, when we are saying, that means gram equivalent of solute divided by total volume occupied by solvent plus solute in terms of liter, expressed in terms of liter. So formula N is equal to equivalents of solute divided by volume of solution in liter, or volume occupied by solute plus solvent expressed in liters. So how it is related to molarity? Normality is equal to molarity times n factor. What's n factor? N factor depends on reaction. How many H plus ions are released in case of acid? For bases, how many OH minus ions are released? In case of redox reaction, how many electrons are getting transferred? Right? So we will understand this in detail when we solve some numerical problem on normality. Let us go for other way to express concentration. Molality. Molality, denoted by small m, is defined as mass of solute per kilogram of solvent. Till now, for normality and molarity, we were talking about volume of solution, total volume of solute plus solvent. But here we are talking about mass, not volume, of solvent, not solution. So it is moles, molality small m is given by, it is equal to moles of solute divided by mass of solvent in kilogram. So unit obviously moles per kg. And how it is different from the previous concentration expressions, normality and molarity? It does not depend on temperature. Why so? It's mass, right? Number of moles of solute divided by mass. So obviously, mass will not depend on temperature. Volume may depend on temperature. Yes, one thing may change, that is, if the temperature is increased, the solubility may increase, or if the temperature changes, the solubility may increase or decrease depending on what type of solution it is. But the expression will not depend on temperature. Hope I could make it clear. Next is mass fraction and mass percent. Mass fraction, mass of any component divided by total mass of solution, that is total mass of all the components. Mass percent, mass fraction multiplied with 100. Why these are used? These are used for this mass fraction and mass percent. These are used for solid mixtures and alloys majorly. And then volume fraction and volume percent. Similar to mass fraction, volume fraction is volume of component divided by total volume of solution, and volume percent will be volume fraction times 100. These are used for liquid solution like alcohol in water. Then mole fraction and mole percent. Mole fraction, moles of component divided by total moles of all components. Mole percent, mole fraction times 100. These are dimensionless quantity, and these are widely used in gas mixture calculations and for colligative properties. Mass by volume percent. That means mass of solute per 100 ml of solution. You mark these things wherever solution, where we are using solution, volume of solution, where we are using volume of solvent, where we are using mass of solvent. Okay. So the formula of mass by volume percent will be obviously mass of solute in gram divided by volume of solution in milliliters times 100. These are used mostly for pharmaceutical calculations, like 5% glucose solution is equal to 5 gram of glucose times 100 milliliters of solution. Now, these are the questions to check your understanding. Learners, you should be able to answer these questions once you listen to my lecture, complete lecture, and go through the slides. So let us go for the questions together. Define mole and Avogadro's number. Differentiate molarity and molality. Directly from slide, you can answer this. What is the relation between molarity and normality? How is mass percent different from mass by volume percent? Express mole fraction and mole percent for a binary solution. Now, what is a binary solution? Where only two components are there. That means only one solute and one solvent, right? Let us practice some numerical problems. First one is on molarity. Calculate the molarity of a solution prepared by dissolving 5 gram of NaOH in 250 milliliters of solution. Let us go for the solution, or will you solve it yourself? Okay, let me go through the solution and you try on your own for some other questions. Yes, obviously practice problems questions will be there at the end of this lecture. So first of all, we need to calculate how many moles, because molarity means moles per liter, moles of solid per liter of solution. So first, how many moles of solute are there? So 5 gram of NaOH is there. How to calculate moles of NaOH? 5 gram divided by molar mass, that is 40 gram per mole. So it will be 0.125 moles. Volume of solution, it is given in terms of milliliter. Let us convert it to liters, dividing by 1000. So it is 0.250 liters. Molarity will be equal to moles by volume of solution in liters. So 0.125 divided by 0.250 moles per liter. It is coming as 0.50 molar. Next one is on molality. Find the molality of a solution containing 36 gram of hydrogen peroxide whose molar mass is given in terms of 34 gram per mole. It's given with the question, but it is easy to calculate as well. 2 hydrogen, 2 oxygen, that means 2 into 1 plus 2 into 16. So it is 34 gram per mole, right? Dissolved in 200 gram of water. So the solution will go like moles of hydrogen peroxide we first need to find out. So that is 36 gram divided by molar mass 34 gram per mole. So 1.06 mole. Mass of solvent 200 gram converted to kg. That means we need to divide by 1000. So 0.200 kg. Molality will be small m is equal to 1.06 moles divided by 0.200 kg. That is equal to 5.3 molal. Normality. Calculate the normality of 0.1 molar H2SO4 solution in terms of hydrogen ions. So, we need to find out the N factor first. N factor for H2SO4 will be 2 because it provides 2 hydrogen ions. Normality will be molarity times N factor. So, 0.1 times 2, that is 0.2 normal. Mass percent. A solution is prepared by dissolving 10 gram of NaCl in 90 gram of water. Calculate the mass percent of NaCl. So we have read the question. Now it's time to solve it. Total mass of solution we need to find out. It will be solute plus solvent. So 10 gram plus 90 gram, 100 gram. Mass percent of NaCl will be 10 gram of NaCl divided by 100 gram of solution. That is mass fraction multiplied with 100 will give you mass percent. It's coming as 10%. Now on mole fraction, calculate the mole fraction of ethanol. What is the formula of ethanol? C2H5OH. So it's easy to find out the molar mass now, but it's given in the question 46 gram per mole. In a solution containing 46 gram of ethanol and 180 gram of water, molar mass is given 18 gram per mole. So first, number of moles of ethanol we need to find out, right? So let us go for the solution. Moles of ethanol is found out. It is 1 mole, obviously. Moles of water, 180 gram divided by molar mass, that is 18 gram. So it is 10 moles. Mole fraction will be 1 divided by total mole, 1 plus 10, that is 11. So 1 by 11 is 0.091. Now, time for practice problems as I had promised. So these are the questions. Go through them, solve it. If you have any doubt, reach back to me. You can comment, you can send message, or if you want more questions, I can upload some PDF file. Please reach back to me. Thank you. Please wait for the next topic coming up soon. Thank you.